morning, good evening, good afternoon, depending wherever you are watching on the blog. Today we are just going to continue with our series of titration, and currently we are on titration 7 in as far as the series of titrations is concerned. So we are just going to do some few questions here. Some few questions in the mode concept. So we are just going to go through the procedure. Titrations Practical 7. You are provided with 1.8 grams of magnesium powder labeled solid B, dilute hydrochloric acid solution P1, 0.8 molar sodium hydroxide solution P3, and phenolphthalein indicator. You are required to determine the concentration of dilute hydrochloric acid P2 in moles per liter. This is the procedure. Using 100 ml measuring cylinder, measure 100 cubic centimeters of dilute hydrochloric acid solution P2 and put it into 250 ml beaker. Add procedure number 2. Add all solid P into the acid in the beaker and stir the mixture with the glass rod until the effervescence stops. In this case, solid P, it is this one. Solid P, it is magnesium powder, solution P. It's supposed to be solution P. Solution P. Then, procedure number 3. Label the resulting solution P4. Fill the burette with the solution P4 using a clean pipette filler. Pipette 25 cubic centimeters of solution P3 into a clean conical flask. Add 2 to 3 drops of phenolphthalein indicator. Procedure number 7. Titrate the solution P3 with the solution P4 from the burette and record the results in the table above, in this table. So in this case, that we will just assume that as usual, we have done our titration. And in this case, these are the results that we got from our titration. We start, first of all, we start from the zero mark, 0.0. And then we just assume that we have titrated, and then the end point has come to 25.3. And then we refill the burette maybe up to 10.3. We refill the burette with the solution P4 up to 10.3 mark. So we will titrate, and the end point comes at 35.3. Then we refill the burette. Again. Maybe let us say that we have refilled the burette up to the 10.3 mark again. So now, in this case, it's going to be 35.3. So when we subtract, when we minus this from this, then we shall get 25.3. Then here it's 25.3, 25.0, and then here it's 25.0. Make sure, as usual, you maintain the laws of titration, that the table is supposed to be tabulated in a 0 decimal point. So the questions, we go directly to the questions, where it asks, question 1, it asks, question A, find the average volume of solution P1, solution P4 used. Remember, solution P4 used, it is the one that was put into the burette. It is the one that solid P was reacted in a beaker, and then it completely reacted. That is hydrochloric acid, dilute hydrochloric acid with that solid, of which is what? Magnesium powder. So we are just going to determine the average volume, so that we take the first clause figures, and then we say average volume of P4 is equals to 2, so that it gives us 25.0 cubic. Here it's going to give us, when we add this, it's going to give us 50. You divide by 2, which is going to give us 25 cubic centimeters. Determine the number of moles of solution P3 used. So in this case, we are just going to write the equation first. We are just going to write sodium hydroxide plus hydrochloric acid. It's giving us sodium chloride plus water. This is the liquid, this is aqueous, and then also this is aqueous. So we consider as usual the mole ratio, and the molarity, and then the volume. And then you just go back to the equation, you find that sodium hydroxide in this equation, it is P3. And then this one, it is what? P4. You indicate there accordingly so that you don't mess up in your calculations. The mole ratio, sodium atoms on the reaction side is 1 sodium atom on the product side is also 1. Oxygen is 1, oxygen is 1. Hydrogens are 2, hydrogens are 2. Chlorine is 1 on the reactant side, and the product side is 1. So the equation is properly balanced. Mole ratio is 1:1. Molarity here, we have been given the molarity of sodium hydroxide, which is 0.8 molar. And then the volume here, we have found that the pipette that was used is 25 cubic centimeters. And then here, we have found that the average volume is also 25. So you can just come and write here 25 cubic centimeters. So now the question is asking, we are supposed to determine the number of moles of solution P3 used. Solution P3 used, it is this one, sodium hydroxide. So we are just going to equate if 0.8 moles are in 1,000. Cubic centimeters. So we are just going to say, what about in 25 cubic centimeters. So we are going to cross multiply here, give you 0.8 times 25 over 1,000. 1,000 cubic centimeters. All these are number of moles in the number of moles of HCl, which is P4. So now we are just coming to say that we go back to our calculator here, and then we say 0.8 times 25 divided by 1,000. It's going to give us 0.02 moles. Remember, we have just found the number of moles that reacted here in 25 of this. But the question is trying to ask us to determine the number of moles of solution P3. P3 is sodium hydroxide. So now we are supposed also to get the number of moles. Since the number of moles is 1:1, so we are just going to say 1/1 times 0.02 moles, which is going to give us 0.02 moles. We have answered that question. So we go to go to question C. Determine the number of moles of solution P4 used. So I just come here. Determine the number of moles of solution P4 used. P4 used. So the number of moles, as usual, we are just going to come here and then say, if these ones, if the molarity can be able to give us this, let us just be very fast. We say if 0.8 molar are in 1,000 moles, are in 1,000 cubic centimeters. What about for 25? 25 cubic centimeters. We just put the usual cross multiplying that, and then over 1,000. Then we just get the number of moles, 0.02 moles. If you do your calculations properly, we have answered that. Then, this is A, B, this is C, then we answer now D. D, it says that determine the number of moles in 100 cubic centimeters of solution of P4. Determine the number of moles. Determine the number of moles. Determine the number of moles in 100 cubic centimeters of solution P4 of solution P4 used. So in this case, we are just going to approach it this way. We have been told that we are supposed to determine the number of moles. So we are just going to equate if 0.02 moles